Alright, so one of the new additions to FumeFX 2.1 is the CFL condition, and you'll see maximum simulation steps here. Rather than before it was simulation steps by itself. This isn't the same as where you're doing sub-frame simulations. It's more, it will dynamically adjust and begin to sub-step where necessary to keep a consistency between your CFL condition. So, in other words, if I have something that's really fast moving through the scene, this CFL condition will essentially control how many sub-steps it will do to keep it consistent. In other words, this value of 5 is 5 voxels. So if I have an object that is moving more than 5 voxels per simulation step, or I should say per frame, then I'll want to adjust my simulation steps to control that. And I can essentially control my CFL condition to be much larger if I wanted to allow for faster movement, or I can tone it back, and that way it's going to want to substep a lot more frequently to match that. And again, I can set up how many times I want to substep it. So I can set something like 20 in here. It doesn't mean it's going to simulate 20 frames per frame anymore. As we can see, at the beginning it's very slow, it doesn't move much, so it's simulating pretty much one frame. I think we can actually read it in here. Yeah, so right now it's doing 2 frames right now because it's beginning to expand and get hot and move faster. At the same time, if I were to go and add in a sphere and animate this shooting through the scene pretty quickly, I might even make that a little bit quicker. Bam. Alright, so if I was to go back into FumeFX and add my FumeFX source and select my sphere, and lastly, just to really kind of make this point come across, set the speed multiplier to 3. Essentially what that does is it will just make it react 3 times as much to it, based on temperature or however it wants to calculate it, but the velocity will push it away a lot more. So now this is going to move through it, it's going to hit it really quickly. And I might just offset the timing just a little bit, just that way the particles have gotten up a little bit and I can hit it and kind of stir it up a bit more. So I've set my MaxIterations to 20, which means that with this fast moving object, if the fluids begin to move more than 5 voxels within a single step, it's going to want to subframe step it. So it essentially will calculate, like divide the amount that it needs to do it based on the divide by CFL condition. So in other words, right now it's fine, but then this object now is going to begin to move through it. So we'll notice that we're going to stick on frame 18 a lot longer because it's subframe sampling, let's see, 10 times per frame. And this could very well expand more, but we set the cap to 20. So this is a lot better because before it was an absolute value. So it meant that if you wanted to subframe sample, like if you wanted to sample more substeps, and you can see this is dynamic, by the way, is now 7, so it does dynamically adjust. Before it meant that, okay, well, I have like this one area of my simulation that moves really quickly. Well, I'm going to have to subframe sample the entire thing. I worked on a show towards the end of 2010 that required a lot of slow motion values, and at the same time this was a 450 frame shot. So having to subframe sample that would just become ridiculous. Whereas this way is dynamic, it essentially will work out, like now we're back to 10 and then back to 7. Each frame it'll work out how much it's going to need to subframe sample. And you can set a cap there just in case, like, for some reason some like particle or something misfired and like it shot out really quick, or there was some bug. You don't want to sit here doing 1,000 frames trying to like sample that. So this essentially is now your cap on how often it'll do it. It defaults to 1, which means every frame is just 1, but the CFL condition is a way to dynamically be able to intelligently control that. And that way you're going to get a very accurate sim without needing excess amounts of frames. At the same time, again, using your quality and iterations means that it will react a lot more considerately to your object. It'll give it a bit more calculation detail to work with. So as we can see here, we have the fire comes up and the object moves through, and rather than getting any weird streaks, we're getting a very accurate sim from it. So this is really cool to have. You don't need to use it all the time, but on like fast moving interactions with objects, it can work out really well.